Ionic compounds are made of cations, which are positive ions that come from a metal. Like in this example, we have sodium ions right here. And the negative ions are what we call anions, which are nonmetals. And here is an example, chloride. Now, when they come together, we write the formula for these, telling the ratio of these two ions together. So we write NaCl because it's 1-to-1 ratio. But if we were to look at the structure, what we notice is it doesn't exist as a single molecule, but rather ionic compounds exist as what we call a crystal array or a lattice. I imagine it like a whole bunch of magnets that you had in a pile, and you know how magnets, when they're in a pile, they can come together? Well, that's kind of what this is like. All the plus and negative charges are next to each other, and you form these crystal lattice structures. Now notice in this example, the cation is calcium, a calcium ion, the metal calcium, and the anion is fluoride, but the ratio, and we'll learn why in just a minute, is CaF2. So on the first one, on sodium chloride, it was a 1-to-1 ratio, and we get a lattice structure that looks like this. Calcium fluoride is a 1-to-2 ratio, and notice that the structure looks a little different. Now for your course, you're not going to have to draw these structures. What I want you just to understand is that ionic compounds, metals and nonmetals, when they get together, don't form individual molecules. Rather, they form these types of crystal lattice structures where you have multiple ions of positive and negative together in a way that is based on their ratios or on how their charges are. It brings up the question then, well, how would I know based on the charges what their formulas might be? And here's the guiding rule. When you add the charges of the cations and the anions together, the pluses and minuses, it must overall equal 0. So basically, all the positives and negatives must cancel out. So when I'm thinking about writing a formula, which is something you have to do quite often in ionic compounds, one of the first things that I need to let you know is that it's always going to have the metal written first, followed by the nonmetal. So if I'm thinking about it, that means the metal is a cation, right, a positive ion, and the nonmetal would be the anion. So it's always the positive ion followed by the negative ion. Now look at these first three examples. We have Na with a plus and F with a minus, and we get NaF. Mg with a 2 plus, O with a 2 minus, and we get MgO. Al3 plus and N3 minus, and we get Aln. Now what all of these have in common, if I erase my writing here, what all of these have in common, these first three examples that I've given you, is that the charge on the cation equals the charge on the anion. So that means it's a 1-to-1 ratio because a 1 plus and a 1 minus added together equals 0. A 2 plus and a 2 minus added together and equals 0. 3 plus, 3 minus added together and equals 0. So in this first example right here, if the charge, well, I want to rephrase that. If the number of the charge is equal for the cation and anion, then it's a 1-to-1 ratio. So, for example, if I had a barium with a 2 plus and a sulfide with a 2 minus, this has 2 and this has 2, so they're the same, so the formula would just be one of each, BAS. And that's true anytime their two charges are the same. Okay, so let's take a look at the next example then, because they're not always the same. So in these three examples right here, they're not the same. So when I look here, if I have a 3 plus and a 1 negative, it's going to take 3 chloride ions to balance it, right? Because we'd need 3 positives and 3 negatives. And so the formula is Al, right here, Cl with a 3, because it takes 3 chlorides. All right, let's look. I'm going to erase that so we can look at the next one. So let's look at the next one. This K has a 1 plus, and sulfide has a 2 minus. So to get those to be equal, I would need 2 of those, because that would give me a 2 plus and a 2 minus. So if you look at the formula, you say K with a 2 and then just an S, because you only need one of them. And on the last one, this would probably be the hardest to reason, maybe, especially for some of you. If this is a 3 and this is a 2, okay, so the first number that a 3 and a 2 have in common would be 6, right? So, because a 3 and a 2 won't cancel. So if I had 2 of these, that would give me 6, and 3 of those, it would give me 6, and so the formula is Fe2O3. Now you can think about it mathematically like that, because remember, if we go back to this rule up here, that when we add the sum of the charges, they have to equal to 0, then we could use our math that way. But luckily there's a rule that they call it the crossover rule, and it looks like a trick. Maybe I don't even know if it would be a rule, but it's a shortcut to helping you figure out quickly how many you would need of each ion. Now the crossover doesn't work very well for these up here. You have to really think about it. When it's a 1-to-1 ratio, when they're the same, you're not really going to want to use the crossover. But when you have different charges, this is how you can think of it. You can look at the opposite charges. So look at this first example. So aluminum has a 3, so I look, chlorine needs 3. Chloride has a 1, aluminum needs 1. Potassium has a 1, so we need, oops, sorry, I'm moving my page. Potassium has a 1, so we need 1 sulfur. Sulfide has a 2, so you need 2 potassium. So it's crossover. Let me write an example that maybe is not on the page. So let's say I have magnesium, which I would know the charge. Magnesium is in group 2A. If you're not sure how I'm going and getting the charges, go back to the first video and watch how we can predict the charges of the main group elements based on their location on the periodic table. So magnesium would have a 2 plus. Iodide, which is a halogen, has a 1 minus. So to get the formula, so for magnesium, I look up here and I see iodine has a 1, so I would just need 1, so you don't write a charge. For the iodine, I would look right here at the 2, and so iodine needs 2. So then my formula is MgI2. Right? Because Mg, I need 1 because iodine has a 1. Iodine, I need 2 because magnesium has a 2. Now, I'm not moving charges or anything. This is simply a shortcut to help me figure out the charges. So why don't we try a few examples? Okay, so I'm going to write some examples here. Now, I am going from the ions. Again, if you need to review how I know what charges are on the ions, please watch the first video. So there's a few. Let me see what else I could do. And okay, there's a couple. So let's take a look at these. So these are just the ions. And if you were given the names, so for example, if I had written sodium and bromine, if you were given the names of the elements, you would need to use the periodic table to find that sodium is a +1 and bromide is a -1. Okay, so to figure this out, you use the periodic table, and that is video 1. I'm not going over that again in this video. Now, in order to figure out the formula, for ionic compounds, you must know the charges. Okay, so I have the charges here, but I'm going to write that down. You must know the charges to determine the formulas. Okay. So, how I would approach it is I would look at the charges. And if they're the same, like a 1 and a 1, then I know it's a 1-to-1 ratio. Right? If they're the same, because they cancel, I only need one of each. A 2 and a 2 would cancel. I only need one of each. Notice when I write the formula, I'm not writing any charges. Okay, now in this example, I have different charges. So when you have different charges, you can use the crossover. So lithium, I would look at the charge on oxygen on the number, and since the number there is a 2, I need 2 lithiums. Oxygen, to figure out how many I need, I look at the number on lithium, which is a 1, and I just write, I just need 1 oxygen. So I'm able to look at the opposite charge to help me figure out how many of each ion I need to make my formula. So magnesium, like how many magnesium do I need? I look up at the chloride ion, and it's 1, so I say I only need 1. The chloride ion, I look up at magnesium. It's called crossover because you're looking at the opposite one. And the magnesium's a 2, so I need 2. Now notice in the formulas, I'm writing the numbers as a subscript, which means it goes below the letters. And on the ions, the charges are a superscript, so they go above. Now this last one, I have aluminum, so I'd look up at sulfur, and it's a 2, so that'll take a 2 aluminums. And then for the sulfur, I look at the 3, and so then it would take 3 sulfurs. So for these 3 right here, because their charges were different, I used the shortcut called the crossover method. And again, it's not a trick, it's just a shortcut.